December 17, 1942, and the Willys Overland factory floor in Toledo, Ohio, was about to witness something nobody wanted to see. A brand new MB Jeep sat mounted on the test rig, its rear axle connected to a series of hydraulic rams designed to simulate the absolute worst conditions a military vehicle might face. The engineers had run this test dozens of times before. Load the axle progressively. Record the stress points. Verify it meets the Army's specification of 2100 lb of cargo capacity. Standard procedure. Except this time at just 1850 lb, the axle housing cracked with a sound like a rifle shot. The room fell silent. Men in grease-stained overalls exchanged glances that spoke volumes. The design wasn't holding up. Inspectors rushed forward, measuring the fracture, noting every chip, every warped edge. The Army's specifications were clear, but the steel simply couldn't bear the weight. Whispers of frustration and disbelief rippled through the factory. This was supposed to be America's workhorse, a vehicle that could carry soldiers, ammunition, and supplies across deserts, forests, and mud-choked roads. Yet here it was, failing at barely half its rated limit. In the corner, a quiet figure watched. A metallurgist who had spent years studying alloys, experimenting with compositions that the industry had deemed too radical, or even banned. He knew the problem wasn't the Jeep's design, it was the steel itself. Conventional alloys had reached their limits, and wartime demands required something stronger, something smarter. His mind raced, imagining a solution that could triple the axle's load capacity, defy the battlefield's brutal conditions, and keep America's convoys moving. Outside the factory, the winter wind cut through Toledo like a knife. Inside, the metallurgist made a silent vow. If the Army and the engineers wouldn't embrace innovation, he would find a way to force it into existence. The fate of countless Jeeps, and the soldiers depending on them, rested on his next move. The metallurgist, Dr. Henry Caldwell, had earned a reputation in small circles as brilliant but unpredictable. He had spent years in relative obscurity, experimenting with steel alloys that deviated from conventional wisdom. Many of his ideas were considered too radical or outright banned by the Army's procurement guidelines. Yet as he stared at the fractured Jeep axle, he knew that conventional steel would never meet the demands of modern warfare. The war had changed everything. Soldiers needed vehicles that could bear the weight of their lives, supplies, and ammunition over unforgiving terrain. Back in his modest lab, tucked behind the main factory floor, Caldwell pulled out his notebooks filled with experiments, chemical ratios, and previous failures. He recalled the tests he had conducted years earlier, when his supervisor had laughed at his attempts to alter carbon content and adjust heat treatment techniques. Those early alloys had been dismissed, forbidden even. But now those ideas felt prophetic. The existing Jeep axles had been failing on test rigs and, more importantly, in the field. Every convoy, every supply route, depended on solving this problem immediately. Caldwell began by reviewing the Army's specifications. He noted the repeated failures in torque, bending, and fatigue tests. Each cracking axle told a story. Ordinary steel, even high-quality steel, lacked the resilience needed. He ran simulations in his mind, imagining the way atoms aligned under stress, how heat treatment could alter crystalline structures, and how even minor tweaks might yield extraordinary strength. He sketched diagrams on the lab table, equations scribbled across paper like a map to salvation. Army inspectors and factory engineers were skeptical. Many considered Caldwell's banned ideas a waste of time. They preferred to stick to standardized steel formulas, safe and approved. Yet Caldwell pressed on, knowing that the battlefield demanded innovation, not bureaucracy. He secretly began sourcing alternative alloys, small quantities of high-carbon and nickel steels, combining them in a furnace hidden from prying eyes. Each batch underwent tests, heated and quenched, hammered and bent, until he identified the right combination that could endure far beyond the standard limits. Word of his experiments began to leak, drawing curiosity and concern alike. Supervisors warned him about regulations. Some called it insubordination, but Caldwell had no choice. Jeep convoys in North Africa were already reporting catastrophic axle failures. Soldiers' lives were at stake, and the war would not wait for bureaucracy. Finally, after weeks of experimentation, Caldwell produced a steel alloy that promised what conventional formulas could not. Axles capable of handling triple their normal load without cracking or warping. The laboratory smelled of molten metal and oil, the air thick with tension and anticipation. If this worked, the Jeep could transform supply operations, enhance troop mobility, and save countless lives. If it failed, Caldwell risked disgrace, the Army's wrath, and another setback for the war effort. With the first prototype axle cast, Caldwell prepared for testing. The lab was silent except for the hiss of steam and the occasional clank of tools. As the axle cooled, he knew the next step would be decisive. The Army would either recognize the innovation that could save the war, or reject it, sticking to standard, inadequate steel, condemning countless soldiers to unreliable vehicles. The first prototype axle, forged from Caldwell's banned steel formula, gleamed in the dim light of the test rig. Engineers gathered around, some skeptical, some curious, as the Jeep was mounted and prepared for the ultimate stress test. Hydraulic rams were set to simulate battlefield conditions, heavy loads, uneven terrain, and constant vibrations. The previous axles had failed at 1,850 pounds. This one had to surpass that without a single fracture. Caldwell wiped sweat from his brow and gave the nod to start. Slowly, the rams pushed the axle, increasing the simulated cargo weight. The room held its collective breath. At 2,100 pounds, the axle held. At 2,500, still no signs of stress. Engineers exchanged nervous glances. This steel was unlike anything they had seen before. At 3,000 pounds, the test reached a critical point. A tiny creak echoed, then silence. The axle had survived. The men in the room felt a mixture of disbelief and awe. Caldwell allowed himself a small, quiet smile. The next step was field testing. Convoys of jeeps were loaded with triple the standard cargo and sent across rough terrain. Gravel roads, mud, steep inclines, and shallow river crossings. Observers recorded every wobble, every strain on the axle. Crews noted that the trucks handled unusually smoothly despite the overload, the suspension working in harmony with the reinforced steel. Caldwell accompanied one convoy himself, riding in a jeep while soldiers marveled at the vehicle's resilience. Axles that would have previously twisted or snapped held firm, even under the harshest conditions. Skeptics in the Army began to pay attention. Reports trickled in from North Africa, where supply convoys had suffered catastrophic axle failures. Now, news reached them that jeeps outfitted with Caldwell's new steel axles were delivering food, ammunition, and medical supplies without incident. Soldiers praised the trucks for their reliability, and mechanics no longer cursed under their breath at warped housings. The difference was clear. Caldwell's alloy had solved a problem that had plagued the Army since the Jeep's inception. Despite mounting success, Caldwell remained cautious. Every test, every convoy run was meticulously documented. He adjusted heat treatment procedures, refined forging methods, and ensured that the steel's molecular structure was consistent across every axle produced. The risk of failure had not vanished, it had merely decreased. Each Jeep became a testament to the quiet ingenuity of a man who refused to accept limits imposed by outdated thinking. By the end of the month, Caldwell's prototype had completed dozens of field tests. Axles that once shattered under stress now survived triple loads, extreme temperatures, and grueling terrain. For the first time, the Army could rely on its Jeeps, not just as transport vehicles, but as lifelines for soldiers across battlefields. Caldwell's banned steel formula was no longer a secret. It was a quiet revolution, reshaping the backbone of America's mobile forces. By early 1943, Caldwell's steel axles were ready for large-scale deployment. The Army approved a batch of Jeeps fitted with the new axles, and they were shipped to North Africa, where supply lines ran across scorching deserts and jagged terrain. The engineers were anxious. This would be the true test. Laboratory results and small convoy tests had been promising, but nothing compared to the grueling conditions of actual combat zones. Convoys rolled out from makeshift supply depots at dawn. Each Jeep was loaded beyond standard capacity, rations, ammunition, water, and medical supplies stacked high. Soldiers, mechanics, and drivers watched with cautious optimism. Many had lost faith in the reliability of the Jeep's axles, having endured countless breakdowns during previous missions. Now, every eye followed the first vehicles as they rumbled across the desert sands, their reinforced axles quietly bearing the triple load. The journey was treacherous. Sand shifted under the tires, forming dunes and hidden pits. Rocks tore at undercarriages, while narrow passes between cliffs tested suspension and strength. The new axles endured it all, flexing without breaking, absorbing shocks that would have destroyed standard components. Drivers began to realize that the Jeeps felt different, stronger, steadier, almost unshakable. Engineers took careful notes, observing minimal wear and no fractures. Yet challenges arose that Caldwell had not fully anticipated. Some convoys encountered sudden rainstorms, turning desert paths into mud-choked quagmires. While the axles themselves held firm, the Jeep's tires slipped, engines strained, and drivers were pushed to their limits. Mechanics worked furiously, adjusting loads and performing quick repairs, but each vehicle remained intact, a testament to the strength of the steel inside. Soldiers whispered in awe. It was as if the jeeps had gained a second wind. The success of the first large-scale deployment spread quickly through the ranks. Field commanders sent reports praising the durability of the new axles and requesting more units. Caldwell's work was no longer a laboratory curiosity. It had become a strategic asset. Convoys that once faltered and delayed frontline operations now moved swiftly and reliably, supplying fuel, ammunition, and food to troops who depended on every delivery. By the end of the deployment, jeeps equipped with Caldwell's banned steel axles had completed missions previously thought impossible. They crossed deserts, rocky hills, and mud-choked roads, carrying triple their intended loads without incident. The quiet engineer in Toledo had changed the game. The backbone of the Army's mobility was stronger than ever, and the unsung heroism of one metallurgist had kept countless soldiers alive and supplied. The triumph of Caldwell's axles did not come without friction. While field commanders praised the jeeps, bureaucrats in Washington hesitated. The Army's procurement office had strict regulations, and Caldwell's banned steel formula was still technically unauthorized. Memo after memo arrived, questioning the legality, safety, and reproducibility of his work. Some officials argued that approving the axles would set a dangerous precedent, allowing engineers to bypass standard procedures. Caldwell, however, knew the real danger lay on the battlefield. Soldiers relying on fragile axles could die if he delayed. Back in Toledo, Caldwell's lab was a whirlwind of activity. Orders came flooding in from the front lines, requesting more jeeps fitted with the new axles. Mechanics and assistants worked around the clock, forging, shaping, and heat-treating the steel. Every batch was meticulously checked. Quality control could not be compromised. Caldwell personally supervised, adjusting furnace temperatures and quenching processes to ensure that each axle met the extraordinary standards he had devised. Yet tension grew. Rival engineers, who had opposed Caldwell from the beginning, began circulating reports suggesting flaws in his alloy. They argued that overloading the jeeps might cause catastrophic failures in extreme combat situations. Their voices, once marginal, now carried weight in committees and hearings. Caldwell defended his work passionately, citing test results and field reports. But bureaucracy moved slowly. He spent nights drafting detailed explanations, diagrams, and calculations, attempting to convince skeptical officials that the steel was safe and necessary. Meanwhile, the soldiers in North Africa were discovering firsthand the advantages of Caldwell's innovation. Convoys moved faster, tires gripped sandy terrain better because the axles flexed without braking, and supply missions once deemed impossible were now routine. Letters from officers described jeeps bearing triple their usual load, delivering fuel and ammunition across miles of desert without a single axle failure. Every report strengthened Caldwell's case, but each bureaucratic delay weighed heavily. The struggle between innovation and regulation reached a breaking point when a high-ranking inspector demanded that production halt until further approval. Caldwell faced an impossible choice: obey orders and risk failing soldiers in the field, or push forward in secret, risking his career and legal repercussions. The metallurgist's determination was unwavering. He knew the jeep was more than a vehicle. It was a lifeline. Each axle produced, each convoy completed, could tip the balance of survival for countless troops. By late 1943, Caldwell's persistence paid off. The Army reluctantly granted approval for mass production, but with strict oversight. The bureaucrats had lost the argument to the real-world evidence of durability, reliability, and battlefield necessity. Caldwell's banned steel was no longer an underground innovation. It was officially part of America's war machine. Yet the experience left him wary. He had seen how slow, cautious institutions could endanger lives while brilliance waited in the shadows. With approval secured, production of Caldwell's banned steel axles ramped up. Factories worked tirelessly, pumping out jeep after jeep, each equipped to carry triple its intended load. For soldiers in the field, the difference was immediate and tangible. Convoys moved faster, carrying heavier supplies, and mechanical breakdowns, a constant source of frustration, plummeted. Caldwell's innovation was no longer theoretical. It was reshaping the daily reality of the war. In North Africa, the impact became undeniable. Supply routes that had once stalled under the weight of overloaded jeeps now flowed smoothly. Soldiers praised the reinforced axles, noting that vehicles climbed steep dunes, crossed rocky terrain, and traversed muddy stretches without incident. Engineers accompanying convoys marveled at the steel's resilience, comparing it to standard axles that had twisted and fractured under much lighter loads. Letters and telegrams arrived from commanding officers, describing jeeps hauling ammunition, water, and medical supplies where older vehicles had failed. The reliability of Caldwell's axles had a strategic effect. The speed and consistency of supply convoys meant that tanks, artillery, and infantry units received the resources they needed when they needed them. Operations that once required careful planning around vehicle limitations could now proceed with confidence. The band steel had quietly become one of the most important logistical advantages the Allies possessed. Yet the field was not without challenges. Desert storms and mudslides tested even the most robust axles, and overloaded jeeps still faced mechanical strain in extreme conditions. But unlike their predecessors, Caldwell's steel held. Soldiers adapted their driving techniques to maximize vehicle performance. Mechanics focused on maintenance rather than emergency repairs, and officers adjusted tactics to take advantage of the newfound reliability. Caldwell himself received field reports with a mixture of pride and apprehension. Each letter, each photograph of a jeep triumphantly crossing a treacherous landscape, reminded him that his work was saving lives. Yet he also knew that any lapse in quality or oversight could undo months of progress. He doubled down on inspections, refining heat treatments and forging methods to maintain consistency across every axle produced. By mid-1944, the results were undeniable. Jeeps equipped with Caldwell's axles were outperforming expectations, supplying frontline troops across Europe, North Africa, and beyond. The war machine was moving faster, heavier, and more efficiently, all because one metallurgist refused to accept conventional limits. In the dusty roads, rocky passes, and mud-choked paths of battle, Caldwell's innovation had become indispensable, a silent backbone of the Allied advance. July 1944, southern France. A convoy of jeeps loaded with ammunition, food, and medical supplies set out from a forward supply depot. The mission was critical. Allied forces were advancing rapidly, and every delay could cost lives. Each vehicle was equipped with Caldwell's band steel axles, now proven in prior deployments. Yet this mission would push them to the ultimate test. The convoy faced a landscape scarred by war, cratered roads, collapsed bridges, and scattered debris from earlier battles. Drivers maneuvered cautiously, aware that one misstep could damage the cargo or, worse, strand them miles from support. Despite the obstacles, the jeeps moved steadily. Observers had expected the overloaded vehicles to strain the axles, but each truck pressed forward with surprising resilience. Dust billowed around spinning tires, engines roared in unison, and the reinforced steel quietly absorbed every shock, every jolt. Suddenly, a washed-out section of the road loomed ahead. Mud and debris had created a natural barrier, threatening to halt the convoy. Drivers hesitated, then pressed onward, relying on the extra strength of Caldwell's axles. Trucks creaked and groaned under the triple load, yet no cracks appeared. Mechanics riding along monitored every detail, ready to assist if failure occurred. Soldiers cheered quietly as the first few jeeps crossed the treacherous patch without incident. Confidence spread through the convoy. Enemy artillery fire began to ring out from distant hills, adding urgency to the journey. Drivers accelerated, taking risks to deliver supplies to the front lines. Under normal circumstances, standard axles would have buckled. Today, Caldwell's steel held firm. One jeep, overloaded beyond specifications, barreled across a makeshift bridge that wobbled precariously over a ravine. The axle endured, flexing but unbroken, and the vehicle made it to the other side. Soldiers and mechanics exchanged looks of astonishment, realizing that the metallurgist's formula was performing miracles under conditions no laboratory test could replicate. By nightfall, the convoy had completed its mission. Every jeep arrived intact, cargo untouched, and no axles had failed. Soldiers unloaded supplies quickly, and officers filed detailed reports, emphasizing the critical role Caldwell's innovation had played. Word of the mission's success spread through the ranks, turning skeptics into believers. Caldwell's band steel was no longer just a solution. It was a game-changer, a silent hero keeping the machinery of war running smoothly. In the aftermath, Caldwell reflected on the journey from laboratory to battlefield. His meticulous calculations, secret experiments, and unwavering determination had transformed a simple jeep axle into a lifeline for soldiers. The success of this convoy proved what he had long known. Innovation, even when dismissed or banned, could triumph over bureaucracy and adversity, ultimately saving lives and altering the course of the war. By late 1944, Caldwell's band steel axles were in mass production, equipping thousands of jeeps across multiple theaters of war. The success of individual convoys had demonstrated the steel's resilience, but the real test came as supply operations scaled up. Entire divisions depended on these vehicles to deliver critical supplies over treacherous terrain. often under enemy fire. Caldwell's innovation was no longer a secret. It had become essential. Convoys in Italy, France, and the Ardennes moved with unprecedented reliability. Trucks packed with ammunition, medical supplies, and rations navigated muddy roads, rocky inclines, and snow-choked passes with remarkable consistency. Soldiers noticed a difference immediately. The jeeps handled heavier loads without strain, reducing the need for repairs and minimizing delays. Mechanics marveled at the durability of the axles, which flexed under extreme pressure, yet remained unbroken. Reports flowed back to Washington, emphasizing how Caldwell's formula had transformed logistics and mobility on the battlefield. But with widespread use came new challenges. Some officers pushed the jeeps beyond even the reinforced limits, eager to maximize efficiency. Convoys carried supplies far exceeding tested specifications. In one instance, a unit attempted to transport an entire artillery payload in a single convoy. The axles groaned under the stress, and drivers braced for potential failure. Yet the steel endured, bending slightly but refusing to break. Soldiers relied on their experience and ingenuity to navigate obstacles, while the axles silently absorbed the load. Caldwell followed the developments closely from Toledo. Field reports and photographs arrived daily, showing jeeps traversing rivers, climbing steep ridges, and crossing crumbling bridges. Each image confirmed what he had long believed. The right alloy, forged and treated properly, could withstand the most punishing conditions. It was more than metallurgy. It was trust, responsibility, and life-saving engineering applied on a massive scale. The impact extended beyond jeeps. Other vehicles, trucks, and light artillery benefited from adaptations of Caldwell's steel. Commanders began to redesign logistics strategies around the newfound reliability, sending heavier loads over previously impossible routes. The efficiency of Allied supply lines improved dramatically, giving the frontline units a strategic advantage. In a war defined by speed, mobility, and resourcefulness, Caldwell's band steel quietly gave the Allies an edge that few could quantify, but everyone could feel. As winter approached, Caldwell reflected on the journey from obscure metallurgist to unsung war hero. The laboratory experiments, clandestine tests, and months of bureaucratic resistance had culminated in a tangible, battlefield-altering innovation. The axles had proven themselves in every imaginable condition, and the jeeps that depended on them were now more than vehicles. They were symbols of perseverance, ingenuity, and the quiet power of science in the service of victory. Spring 1945 brought calm after months of relentless combat, and the scale of Caldwell's impact became undeniable. Field reports arrived from every theater. Jeeps equipped with his band steel axles had completed missions that once seemed impossible. Supply convoys crossed deserts, mountains, and mud-choked forests, carrying triple loads, keeping troops fed, armed, and mobile. No other innovation of its kind had achieved such widespread, measurable results. Caldwell received official commendations, but recognition was slow and understated. Army brass praised the reliability of the vehicles, yet the metallurgist himself remained largely in the shadows. For him, the victory was in the field, not in ceremonies or paperwork. He reviewed detailed reports from engineers, officers, and mechanics who described jeeps surviving extreme terrain, overloaded convoys, and emergency maneuvers without a single axle failure. Each success reinforced what he had always known: meticulous experimentation, daring innovation, and persistence could overcome even the strictest rules and the most skeptical observers. The practical implications were enormous. Forward units could advance faster, relying on dependable transport for food, ammunition, and medical supplies. Tanks and heavy trucks, previously limited by fragile axles, began incorporating adaptations of Caldwell's steel, increasing operational efficiency. Military strategists realized that supply line reliability could dictate the outcome of entire campaigns. The unseen work of a single metallurgist had ripple effects across multiple fronts, subtly altering the dynamics of warfare in favor of the Allies. Yet Caldwell's journey had not been easy. Bureaucratic resistance, rival engineers, and fears of untested innovations had threatened to derail progress multiple times. He reflected on how close the project had come to being shelved, and how vital secrecy, careful documentation, and quiet persistence had been to its success. In a war where lives were measured in hours, every decision, every calculation mattered. His band steel had defied doubt and skepticism to become a decisive factor in the effectiveness of Allied mobility. As Europe moved toward victory, soldiers praised their jeeps, often unaware of the innovation hidden within the axles. Engineers marveled at the steel's strength. Caldwell's colleagues, once dismissive, acknowledged the brilliance of his alloy. And though the metallurgist remained modest, content to work in his lab, history had begun to recognize the quiet heroism of his contribution. One man's vision had ensured that vehicles could carry the weight of war itself, safely, reliably, and across distances that had once seemed impossible. By mid-1945, the war in Europe was drawing to a close, and the full impact of Caldwell's innovation was clear. The Jeeps that had once struggled with overloaded axles now performed flawlessly, enabling supply lines to move faster and further than anyone had imagined. Thousands of soldiers owed their survival and operational effectiveness to the quiet work of a metallurgist in Toledo, Ohio. Caldwell, now recognized by Army officials, received commendations for his ingenuity, though he remained humble. He often insisted that the real heroes were the soldiers and mechanics who relied on his axles day after day. Yet there was no denying the truth. His band steel formula had saved lives, expedited campaigns, and changed the trajectory of military logistics forever. In the factories, production continued, and the knowledge gained from Caldwell's experiments began to influence other military vehicles. Trucks, light artillery, and specialized equipment adopted similar alloys and treatments, ensuring that future operations would benefit from the reliability he had pioneered. The lessons of innovation, persistence, and calculated risk were not lost on the next generation of engineers and metallurgists. Looking back, the story of the Jeep axle was more than a tale of steel and machinery. It was a testament to the power of ingenuity under pressure, the importance of challenging conventional thinking, and the life-saving impact one determined individual could have on the course of history. Caldwell's work quietly underscored a simple truth of war. Victory often depends as much on ingenuity and engineering as it does on strategy and courage. The band steel axles became legendary among those who knew the story, a silent backbone of victory. And while Henry Caldwell returned to his laboratory, continuing experiments far from the battlefield, the Jeeps he had strengthened continued their work, carrying the weight of war and the lives of countless soldiers, reliably, faithfully, and triumphantly.